All right. So we're moving on to 4.3, and this question deals with square roots. How many different ways are there to write the fraction 1/2? A lot, an infinite number, right? So a long time ago, mathematicians decided anytime you have a fraction, we want everybody to simplify it. That way, everybody gets the same answer. So 1/2 is the same as 2/4 or 3/6 or 700 over 1400. But we've decided that if a fraction has any common factors among the numerator and the denominator, we're going to divide out those factors, and then we end up with what we call the simplified fraction. And everybody should get the same simplified fraction. Well, square roots also have a series of rules regarding simplification. For instance, if we have the square root of 12, we have decided that we need to simplify that by factoring it down. 2 times 2 times 3. And how do we simplify this? We look for pairs, and we pull those pairs out of the root, and we get 2 root 3. There are an infinite number of ways to write a square root, just like there are an infinite number of ways to write 1/2. So one of the rules of simplification says pull out any pairs that you have of factors inside the square root. Well, similar to that, we have rules about square roots in the denominator. So here I have the square root of 7 over, I'm going to factor this, 4 times 7, 2 times 2. So I pull out a set of 2's, and I get 2 root 7. Oh, in this case, the square roots just cancel. So what's left on top? Not a 0. It's a 1. It is nothing, but nothing for multiplication is different than nothing for addition. The addition nothing is 0. That's the number that doesn't do anything. The multiplication nothing is 1. That's the number that doesn't do anything. So in this case, we just get 1/2. Let's do another one of those. So the top is 3 times 3 times 3. I pull out one set of 3's, and I write it in the front, and I get 3 root 3 over 3. Sorry, root 3. And the root 3's cancel, and the answer is just 3 over 1, which is 3. Why does this simplification work? Well, some numbers are perfect squares. So 4, 9, 16, 25, 36, on and on and on, right? All of those can be square rooted. The square root of 4 is 2, the square root of 9 is 3, and 4, 5, 6, and so on. All we're really doing is taking out the perfect squares. Does 27 have any of those numbers inside it? 9, right? So 27 is the square root of 9 times the square root of 3. What is the square root of 9? It's just 3. So that's all we're doing. We're looking at 27, and we're figuring out, are there any perfect squares inside there? If there are, then we square root it, and we move on. So actually, let's leave that up. What if I had the square root of 72? Do any of these go into 72? 4 does. Anything else? Not 16. 36 does, and 9 does. So which one do I want to use? Do I want to use 4 or 9 or 36? 36, the biggest one. So 72 is just the square root of 36 times the square root of what would be left? What times 36 is 72? 36 times 2. Right? Well, what is the square root of 36? 6 root 2. Now, if we did it the other way, if we broke 72 down, we're going to get 2 times 2 times 2 times 3 times 3. That's 72. Right? Does it have any pairs? Has a set of 2's and a set of 3's. So what comes out? 2 times 3 is 6, and the 2 is left over. That makes sense? Okay. All right. Here's another one. It appears like it doesn't simplify. Right? The bottom doesn't get any easier. Nothing in the top cancels with anything in the bottom. But one of the rules of square roots is you're not allowed to leave a square root on the bottom of a fraction. So you cannot leave root 3 in the bottom. Why? For the same reason that we always simplify 10 over 20. So if I had the fraction 10 over 20, we have agreed that we never leave a fraction in this form if it can be simplified, so we pull out a 5 or a 10 and we get 1/2. So that is called a irrational number. And the instructions for this problem say rationalize the denominator, which means get rid of the square root in the bottom. And to do that, we simply times the bottom by itself. But if I times the bottom of a fraction by root 3, is that going to change the size of the fraction? Yeah. So what do I need to do in order to not change the size of the fraction? Can I just randomly multiply the bottom by root 3? No. Is there a number I can multiply by without changing a fraction? If I multiply a fraction by 4, it's going to get bigger. 1. So the only number you're allowed to multiply by without changing a number is the number 1. So I'm going to multiply this fraction by 1, but it's going to be a weird looking one. It's going to be this. Root 3 over root 3 is the number 1. And multiplying by 1 does not change the size of a number. Okay? So on top, I get 4 root 3. And on bottom, I get root 3 times root 3, which is the square root of 9. What is the square root of 9? 3. That's why I chose root 3. Now, this fraction is exactly equal to that fraction. It's the exact same number. The value has not changed. It just looks different. Now, why would you do that? That looks more complicated than the original fraction. Well, one of the reasons is that way everybody gets the same number. Okay, and yes, this one does look more complicated, but a lot of the time, when you simplify this way, you will turn something complicated into something less complicated. But there are an infinite number of ways to write a number with a square root in it, and we've decided no square roots in the denominator. That way everybody gets the same answer. Let's do another one. That's the exact same problem. All right. Square root of 5 over the square root of 2. So I multiply the bottom by the square root of 2 over the square root of 2. When you multiply radicals, so if I had 3 root 2 times 5 root 3, how do you multiply these? Well, you do outside times outside and inside times inside. So the outside is going to be 15 and the inside is going to be 6. So up here, outside times outside is just 1. 1 times 1. And inside times inside is root 10. Okay? And then what is a square root times itself? Not 1. So what is the square root of 2 times the square root of 2? Outside times outside is 1. Inside times inside is root 4. What is the square root of 4? Just 2. So what happens when I multiply a square root by itself? The square root just cancels. Okay? Now, can I take a 2 out of both of those? No. Because that 10 is not really a 10. It's the square root of 10. If I had 5 root 6 over 20 root 8. Let's not do 8. Let's do 10. Whatever. Let me start over. 5 root 10 over 20 root 6. So this becomes 1 over 5, or 1 over 4. Okay? I can take a 2 out of those, so that would be the square root of 5 over the square root of 3. Or not 5, sorry. No, that's right. Square root of 5 over the square root of 3. But can I cancel those? No. Outside can only cancel outside, and inside can only cancel inside. Okay? You can't cross them. All right, let's do another one. All right, so times this by root 2 over root 2. The top becomes root 14, and the bottom just becomes 2. Can I take a 2 out of those? No. You cannot cancel an inside and an outside. That will never work. Inside can cancel inside, and outside can cancel outside. All right, special right triangles. So you need to remember these two triangles. So 60, 30, 1, 2, square root 3. Okay? And then 1, 1, root 2. So here it says, I have a 30, 60, 90 triangle. I know one side. I want to know side A. But they don't give you a similar triangle. So you need to remember these triangles. Okay, maybe I'll take a picture of this. All right. Oh, it disappeared. How nice. That was really nice of it. So 60, 30, 1, 2, root 3, and then 1, 1, root 2. So we just do the same similar triangle thing that we did before. 3 matches up with 1. So 3 over 1 is equal to A, which matches up to root 3. So A over root 3. Cross multiply. A equals 3 root 3, and then it just wants the decimal answer. Okay. 8 matches up with root 2, and C matches up with 1. So 8 over root 2 equals C over 1. Cross multiply. 8 equals root 2C. Divide by root 2. And I get C is equal to 8 divided by root 2. And it wants the decimal answer, So just plug that into a calculator to get your decimal answer. So you need to remember these two triangles, and I'll leave them up on the board for today. Okay, so this triangle is 1, 1, root 2, and this triangle is 1, 2, root 3. So 7 over root 2 equals c over 1. Cross multiply. C times root 2 equals 7. Divide by root 2, and I get c equals 7 over root 2. And this time it wants the exact answer, which means don't give it a decimal. Can I leave the fraction in that form? Nope, there's a square root in the bottom. So I times the bottom by root 2 and the top by root 2. And that gives me 7 root 2 over root 2 times root 2 is just 2. So that would be the exact answer. Okay. And then over here, 5 over 1 is equal to a over root 3. Cross multiply. A equals 5 times root 3. So that is your answer. All right.